Let's see how to use the washer method when the axis of revolution is vertical instead of horizontal. The start of the problem is exactly the same. We've got to draw this region that we're trying to revolve around an axis. So I'll start by, in the xy plane, I'll draw y is equal to 0. So y is equal to 0 is just the x-axis. X is equal to 1 is this vertical line here. Y equals the square root of x is a sideways half parabola. Okay, so we see here that this is my region of that we're revolving, and I need to identify these points that things are crossing at. In this case, it's pretty straightforward. I don't need to set anything equal to each other. I could easily see that this is the origin, 0, 0, and this is the line x is equal to 1. And if I plug x is equal to 1 into the square root of x, I get y is equal to 1. So that's 1 up here. So there's my region, but it's really messy already. So let me draw a prettier version here on the right. And I also need to make sure I leave room. My axis here is negative, so I'll draw the region in purple. Looks something like this. My axis is vertical, and it's negative. X is negative 1. All right, so there we have my axis. So what would a washer look like in this example? Well, to get a washer, I need a line segment perpendicular to the axis, because when I rotate that line segment to its buddy on the left, that will indeed get me a circle with a circle cut out of it. If I had chosen a vertical line segment instead, what I would end up with is a cylindrical shell. And you can actually integrate using cylindrical shells, but you have to use a different formula. That's not what we're talking about right now. To do the washer method for a vertical line segment, instead of drawing a vertical line, we draw a horizontal line. All right, so I will just leave that horizontal line here. And instead of drawing the washer, I just need to label its inside and outside radii. So here is from the axis to this point, that's my inside radius, little r of, now I put x, but that's no good, because now it's going to depend on these horizontal points here have a fixed y value. So it's going to be little r of y at this particular y value, which is between 0 and 1. So there's my little r of y. My big R of y is this distance from the axis to the outside. Let's start with the big R of y because that's the easiest one to take care of. It's just a simple matter of adding up two numbers, because I know that this distance from the y-axis to the line x equals negative 1, it's a horizontal distance from 0 to 1, so it's just 1. And hey, this line here on the right this vertical line here is also just from 0 to 1. So big R of y is just 1 plus 1, which is 2. So that's easy. Big radius is 2. Great. Okay, what about the little radius? Well, that one's a little bit more going on. What I can do is I can split this up into the distance from the y-axis to this point. So this tiny distance right here, it's horizontal, so it's an x value. It comes from this curve. This curve is the curve y equals the square root of x, but I want an x value because I want a horizontal distance. So what do? I'll just solve for x. X is equal to y squared. And then I just saw a moment ago that the distance from the y-axis to the axis of revolution, this horizontal distance, is 1. So my inside radius, little r of y, is 1 plus y squared. So I've got my inside radius and my outside radius. Now, these are functions of y, but that doesn't make a difference for us. We'll just use the same formula that we usually use, but we'll switch all of our x's for y's. So we'll have pi. Traditionally, we use c and d because they're y values. That just means the bottommost and the topmost y value of the region. And we'll do big R of y squared minus little r of y squared dy. So we're going from 0 to 1. Big R of y is 2 squared minus little r of y, 1 plus y squared, squared. Four minus 1 plus 2y squared plus y to the fourth. So I get 3 minus 2y squared minus y to the fourth dy. I'll integrate. From 0 to 1, I'll plug in top minus, plug in the bottom, get a big fat 0. Be careful when you do that, of course. You know, if you don't have anything that's not a polynomial, plugging in a 0 may not always get you a 0. But in this case, it does just get me a 0. And I'm getting pi, common denominator is 15. So we have 3 becomes 45 over 15. 2/3 becomes 10/15. 1/5 is 3/15. So 45 minus 13, that's 32 pi over 15. And that'll get me the value of that volume.